So thank you guys all for joining us. We're here with Bobby Farlice-Rubio from the Fairbanks Museum Planetarium to do a little Tonight Sky show. So let me stop sharing here and let you take it away, Bobby.
All right. Thank you, Leela, and welcome everyone who's watching. I hope you've had a chance to see the amazing dark skies. I actually wasn't anticipating it to get as clear as it's been the last couple of nights, but there is that Lyrid meteor shower going on. So that's going to be happening, through the end of this week, fading a little bit less and less. But I actually tried for several hours and I haven't seen any. So it may be not a great Lyrid year, but nonetheless, for general meteor shower information, the best time is after midnight. And maybe that's part of the reason why I haven't seen so many. I haven't been able to stay up as late as usual. However, that is going on, and I hope that this clear, cold weather, you take advantage of it to see what else is in the sky. But I want to talk about a new constellation today. And so let me turn on Stellarium here for you guys. And there's that free program that I hope you download and use, stellarium.org. And it's a great way to simulate the sky, and you can go forward through time. And actually thinking about time is what I want to do today, because I want to introduce you folks to the oldest known constellation in human history. So first, let's make our sunset here. You can fast forward time by pressing the L key on your keyboard. JKL, or like the fast forward, fat reverse, and the K is the pause button if you're using Stellarium, kind of like a fast forwarding through a video. Going through the day, and today's sunset will be at 7:43. So right when the sun sets and it gets a little dark, like we've been talking about, you'll see, perhaps before anything else, the bright planet Venus over there in the west, still easily seen for hours after sunset. Oh, I'm going to pause time because I see there's a question coming through. Yes.
Well, it looks like there might be someone actually saw about 20 plus, I think, of the meteor shower you're talking about between 45 a.m. and sunrise just this morning. They were moving fast like airplanes and didn't burn up, but went all the way across the sky. So someone could see them this morning, which is awesome.
Yes. So I'm going to set my alarm clock and try to get up at that time, because that's really the best, most fruitful time to see meteors. If you imagine, I made the analogy on Tuesday about these meteors being like bugs hitting the Earth's windshield. So that's the time in the morning before sunrise, but in the hours before sunrise, when your view of the east is actually lined up with the direction of the Earth's travel. So it's the time when you're looking forward through the windshield, and that's why that's the best time to see most meteor showers. So if you go out at 9 or 10, you're kind of like looking out the back window, and you're going to see a lot fewer of those splattering bugs, so to speak. So thank you for that, viewer. I am really pleased that somebody went out and saw that. Now I'm embarrassed that I haven't had that dedication. I'm going to redouble my efforts to go out there and see the Lyrids this year. But there's always meteors going on, just so everybody knows, and you don't have to have a meteor shower to go and see them. There's a good chance of seeing meteors anytime you go outside and stare at the sky for more than a few minutes. So let's continue with our progression into the night. So there's Venus right there, easily seen. But I'm going to take that highlight off and continue through time until we can see more stars in the sky. And now you can see that Venus, boy, it is very far from where the Seven Sisters are. You might not see them because of that tree. I took this out of the way. This allows us to see where the sun is, even though the ground would block our view. And the Seven Sisters, you might remember, if you've been watching, that on April 8th, Venus was right in front of the Seven Sisters. So in just, a couple weeks, it has moved a considerable distance across the sky over here towards this horn of Taurus the Bull. So that's Venus, and I hope you continue watching that progression. And you may notice that it's getting harder and harder to see Orion late into the night, because now by 8:40, he's already starting to dip below the horizon. This is the last month that we get to see Orion, and then we'll have to wait until fall's hunting season to see the great hunter again. And you'll see his big dog and his little dog behind him, and right above Orion, still visible for a lot longer because of their height in the sky, we've got the Gemini twins. So lots of constellations that we've already covered here. Let me not confuse you with too many illustrations there, but Taurus over here, Orion, Canis Major, Canis Minor, and Gemini, they've been featured much in my programs. I'm sorry for those of you fans of unicorns. I haven't talked much about Monoceros, but maybe you'll see why. It's a very faint constellation. I kind of see a little bit of a horse's head and a little horn here. It's actually using the feet of one of the Gemini twins. So this is not a constellation I talk about much, but it is there too. However, if you've been tuning in over the last couple of weeks, you've probably noticed that I've also recently talked about the stuff in the north. I talked about the circumpolar circle and the stars that are visible all year round. And just as a reminder, if you go into Stellarium, you can put up all kinds of markings. We're going to use a different circle in a moment, but the circumpolar circle are the stars that are around Polaris, and Polaris is the North Star. And we also have talked about how the Big Dipper can help you find the North Star if you use that handle. And here's the scoop, and you slurp the soup from this end of the spoon. Those two slurping stars point you right towards Polaris. So remember this too, that Polaris is the end of the handle of the Little Dipper. So this is a little bit of a review. I hope I'm not going too fast for those of you watching now, but I have covered these constellations in greater detail in previous sessions. But the reason why I want to return to your knowledge of the Big and Little Dipper and the North Star is because I'd said I was going to show you the oldest constellation in human history. And this constellation is easily found if you know where the Dippers are. And right now, his head, his body, and his tail are completely visible. But during the middle of the winter, you can't really see the head, which is the most dramatic part of this constellation. And I don't know if any of the folks viewing now are familiar with oldest known historically constellation. The reason why I say oldest known is because it was the first constellation written down in history, and its description was written down in the cuneiform language, the alphabet invented by the Sumerian people who lived in what is now Iraq in Mesopotamia around 6,000 years ago. So those folks invented the oldest form of writing that we know, and the first constellation they described in their oldest form of writing was Draco the dragon. Draco, not Draco Malfoy, for those of you Harry Potter fans, but this is not the first time that Harry Potter characters have worked their way into our star show, because after all, we've got Sirius in Canis Major, we've got Regulus in the Leo the Lion constellation, and now I have another Harry Potter character, that one called Draco. Well, Draco Malfoy is, of course, Harry Potter's enemy, his foil throughout most of the stories. But in the constellations, I want to show you where you can see the head of the dragon right here. So here are the two eyes, stars with cool names like El Tanin and Rastaban. These are the two stars that make the eyes of the dragon. And let me zoom in a little bit. Maybe it'll make it easier for you to see that his two eyes are in the center of what looks like a little diamond. And that diamond is what I see as the head, although this star may or may not be part of some people's picture of Draco the dragon. I see that as the top of his pointy head. And here is the tip of his pointy nose. Right there, a star called Grumium. And this star, I like to pretend, is a little flame spurting out of his mouth, or maybe his tongue sticking out of the side of his mouth. But if you look at the four brighter stars in this section, you can see how that diamond resembles a dragon's face. And my favorite thing about Draco is that it looks like he's staring right at you, the viewer. So when you go out at night, if you recognize Draco, it feels like you're being watched by something in the sky. Perhaps that's why ancient viewers of the sky, named this so early. It's so evocative. It really does look like a dragon if you add this head to these stars over here. Now, this cluster of stars looks like a jumble, but if you look carefully, you might notice that there's a couple parallel lines that we can make here. And I like to pretend that these two inner parallel lines are the front legs of the dragon. And the other lines back here are his hind legs. So imagine the way a dog looks when he's sitting on his haunches facing you, with his two front legs in front and inside, and the two outer legs outside. Back here, you get this impression of two rectangles, perhaps. And that's how I see the body of the dragon connected to the head. But perhaps you will find him more easily if you start with his tail. So here's the head of Draco. Here are those legs. And close to the legs, you see that there's a loop of stars, sort of a 90-degree chain right here. and it goes right around where the Little Dipper is. So if you remember the Little Dipper, just look at this chain of stars that surrounds the scoop of the Little Dipper and follow it up towards the Big Dipper. And you might see that there is a very long tail. And this tail is pretty cool because it just sort of, it makes him more majestic, more evocative. It makes this dragon huge. If you add all of these stars, here are the legs and here's the head, you get this really cool serpentine dragon. And let me see the illustration from Stellarium. It kind of matches the way I see it in my mind. I put all his legs on this side, but you can see that they even tried to match this illustration's eyes with those two stars, Eltanin and Rastaban. So there's the head of the dragon. I think he's facing more forward, but that's, of course, artistic license. And I'm not sure who the illustrator was, but they did a fine job on most of them. I just disagree with some of the alignments of the pictures. But then, of course, this is all subjective. The picture you see is all up to you. It's not up to me. It's not up to any astronomer. It's more of the fun of the astronomy is to see the picture in whatever way makes sense to you. But do know that that is the constellation Draco the dragon. And one more thing I want to tell you about Draco. Here you can illustrate some of the brightest stars. That makes the tail easy to see. I like to add a little more to the tail with these stars here. But Draco the dragon is close to the North Star, but this might come as a surprise for those of you who are not very familiar with ancient astronomy. But Draco the dragon actually used to be the host of the North Star. There is a star called Thuban right here on the dragon's tail that from roughly 4000 BC to 2000 BC served as the Northern Hemisphere's North Star. So wait a minute. This hasn't always been the North Star? No. Polaris, the North Star that we see now, only started becoming the North Star later during the time of the ancient Greek Empire. And since so much of our astronomy comes from the Greek Empire and the Roman Empire, that's where Polaris got its fame. But before those empires rose, when the folks that became the Greeks and the Romans were hunter-gatherers wearing animal skins, or like Etsy, the famous Italian, Austrian man that was found in the Alps, he lived during the time when this was not the North Star. So this was the North Star, Thuban. And they're close together, but there's something really cool that this has taught humanity. And this change of the North Star also explains why the zodiac constellations dates do not line up with the same dates that they did during the ancient Greek times. Earth is a dynamic system. Earth is a moving planet, and Earth's rotation is pretty constant, but the direction that the North Pole is pointing has not always been the same. So let me stop this sharing of Stellarium just to do a little hand demonstration here. Maybe some of you have played with a gyroscope or a top, a little spinning toy that spins so fast that it can stand up straight. Well, imagine that the Earth's rotation once every 24 hours is like the whirling of a top. Now, if you've ever played with a tabletop top or a gyroscope, you've also noticed that no matter how well you spin it, it's not just going to spin fast, it's also going to do a slow wobble. This slow wobble is called a precession. And this slow wobble is happening to the Earth, but it's very slow for human lifetimes. In fact, the Earth has only gone about a quarter of a wobble, a quarter of a precession since the time of the first written documents in history, like the description of Draco the dragon by the Sumerians. So let me show you how we can see that, because with today's astronomy and the satellites and the precision telescopes that we have, we can actually measure this wobble to a really precise degree. But we know that the wobble has been going on because ancient astronomers wrote down different descriptions of the North Star, and we can track the different North Stars that people used over time, and that allowed us to reconstruct the wobble with historical sources, plus we can see the wobble with modern day instrumentation. So let me go back to Stellarium. If you understand that whole wobbling top precession idea, let me show you the path of the Earth's North Pole wobble, which is actually called the precession of the equinoxes in astronomy. And let me put Stellarium back up. So I'm going to take that circumpolar circle out of the sky. And right below it on the markings menu, you'll see something that says Precession Circles. This is what I'm talking about. There is one for the South Pole, but I don't have any written records that go back that far for the Southern Hemisphere. So I don't know how people made sense of that, but I'm pretty sure Polynesian astronomers and Aborigine astronomers and other folks of the Southern Hemisphere notice similar things happening with their sky. But just so you know, there isn't an exact South Star for the Southern Hemisphere. So in a sense, we're a little lucky. But check out this big circle. Let me remind you, this is the current North Star, Polaris, exactly precisely due north. But this wobble here, this circle, represents how far around in the cosmos the North Pole of the Earth will wobble as it goes around this precession. Now remember, the Earth spins once every 24 hours, but this wobble takes something like 24,000 years to complete one circle. And check it out. If you look carefully, you'll see that Thuban is right here on this circle, which means it almost a quarter of a circle. And just imagine that the North Pole is pointing here now, but if we were to go back in time, we would see the North Pole pointing slightly different directions. And if we had a time machine like in H.G. Wells' ancient novel, from Victorian times, where he could look out the window and watch time go back, he would eventually see the North Pole point here. So what this means is that Thuban would have been due north, and Thuban would have been the one star in the sky that seems to stand still throughout the night. So if you were an ancient Sumerian astronomer looking up at the sky, that would have been your North Star. And Polaris would have done little circles around the North Star. It would have been circumpolar, but it would not have been polar. And Thuban would have been the polar star. So I think this is a really cool thing to think about when you go out in the night sky. So I see we have a question. Let me see if I can answer it. Sure.
So it was interesting. It's someone saying they found a way to get a view from other planets. There's a pull down menu, the same menu where you change where you are on Earth. So it looks like people are trying to see the stars from other vantage points.
Yes, I think that's in the location window. If that's what they're talking about. Yeah, Planet Earth, they made that a drop-down menu. And yes, I have not spent much time playing around with this feature on Stellarium, mostly because our planetarium shows are Earth-based. And however, nothing makes me happier to think that folks that are watching have found out how to do this. And anywhere within the solar system, you will see more or less the same constellations, not more or less, exactly the same constellations. There's nowhere in the solar system that's far enough, out of alignment from where we are that things would look radically different. But one of my favorite things to do in the Lyman Spitzer Jr. Planetarium at the Fairbanks Museum is that I could zoom you out of the solar system and show you how once you get a few light years away from the sun, all those constellations start to disintegrate. It's really strange. Like Orion will fall apart and look like a whole different shape. And then you'll realize that if humans ever do become interplanetary, interstellar travelers, not just from Mars to Earth, but from Proxima Centauri to Earth, then we're going to have to make up new constellations, which is kind of cool. I mean, if you think about that, the first humans to leave the solar system and go to another star system, hopefully this happens sometime in the future, they will be the first humans to see a whole new set of constellations. And that means they get dibs on naming them probably. So who knows, they'll probably name it like, ancient things to them, like SpaceX rocket and laser beam and, microwave oven, because that's what, will be ancient to them perhaps. However, let me go back to Stellarium. So I'm glad Michelle and Emma, thank you so much for pointing out that you can travel to other locations. And just to add to that fun, when you're in Stellarium, you can actually change the landscape. You may notice I've been using a landscape that resembles a Vermont field in summer. It's actually, I think, a place in France called Guérin, but looks like a bucolic place. But if you go to the the sky and viewing options and you go to landscape, there you can see that you can actually put yourself on Uranus now, or Saturn. And what happens is that you lose that hard line of a horizon and you get a fuzzy boundary between sky and ground. Because really, if you're on Saturn or Uranus or Neptune, you're in a place with no land. So basically, if you were an astronomer there, you'd have to have some kind of cool airship that rises through the gas layers to the top layer where it's transparent enough to see the stars. But if you lived there, you'd probably have to float around. And so it's just fun to imagine doing this from other planets. So that's something that you can do in landscape without leaving Earth, just pretending. But if you go to one of these planets in the locations window and then add that landscape, then you can get the full effect. And just imagine who's going to be the first person. Here, there's even a Mars, which gives you a rocky planet horizon, but we'd have to see it during the daytime to do justice to this landscape. But let's see what it looks like when the sun comes up. So, of all the landscapes that we can pull up in Stellarium, the one first, most likely to be seen by real human eyes is this of Mars. And I think I recognize, oh, yep, I do. I recognize the spacecraft that made this panoramic picture possible. That's one, either Spirit or Opportunity. I think it's this Gusev crater, so it's probably Opportunity, the one that lasted the longest of those two twin rovers that got on Mars in 2003. So pretty cool. This robot lasted for 10 years. It was supposed to last for 90 days. It lasted for 10 years or more. And the only reason it stopped working is because, as you can see in this picture, those solar panels got covered in dust. It's actually visible in this picture. And as time went on, the dust got so thick that the solar panels could not get enough sunlight. So basically it stopped charging itself and its batteries died, but the robot never actually broke in any significant way. And the new Mars rovers, like Mars 2020 Perseverance, that's going to be launching this year. Some hopeful news for 2020. Pretty cool thing to think about. That robot, they have nuclear reactors inside. It's not so scary as it sounds. It's actually just what's called an RTG, a radioisotope thermal generator. If you saw the movie The Martian with Matt Damon, he was playing Donna Summer's Hot Stuff when he picked up one of those RTGs and put it inside the cabin. It made a lot of heat, but it also uses the radioactive decay of plutonium to generate electricity. And if you think RTGs are scary, the first generation of pacemakers that were inside of human chests ran on RTGs made of plutonium. So there are many humans alive today that have had a pacemaker running on the same kind of battery that's going to be powering Mars rovers like Curiosity, that's been there for 8 years, and Perseverance, that's going to land this year. And those generators last for about 10 years. So they make heat, so that's what you need. And they're not solar powered, which means you don't have to worry about the dust. So what's the question we've got coming in, Leela?
It looks like, just asking, is the North Star the center of the circumpolar circle for all planets in our solar system? So
no, I'll tell you that, because the axis of rotation that a planet goes around, its pole could be pointing in many different directions. So the constellations will look the same from planet to planet, but the way they move across the sky will change depending on the tilt of the axis. And this is one of the funny things about the planets. For example, Venus, there's too much clouds, you wouldn't see it, but Venus rotates backwards from most of the other planets. So the sun rises in the west and sets in the east on Venus. You won't see the sky, but just imagine how differently it would look if you could rise above the clouds and everything would be going backwards. But if you were on Uranus, well, orbiting around Uranus or floating in an airship in Uranus's atmosphere, that planet has the axis of rotation the most radically tilted of all the planets. It actually appears to have been hit by something long ago that caused it to flip over almost 90 degrees. So let me make this clear, and I'm not spending a lot of time talking about Uranus, but its North Pole is almost, horizontal compared to the vertical pole. Ours is tilted 23.5 degrees, and that's what gives us the seasons. That's another day. We'll talk about that. But on Uranus, if the Earth is tilted 23.5 degrees off of perfectly perpendicular to our path of travel around the sun, we're 23.5. Uranus is 90 degrees almost. So what happens on Uranus, because it takes 80 years to go around the sun, is that one side of Uranus will be in the dark for about 40 years. And the other side will be in the sun for 40 years. And then slowly they transition so that there's a lot of science fiction written about places like this. I think even in Star Wars, they have a planet that has, where Darth Maul was born, or it's permanently dark on one side. Could you imagine spending a generation in the dark? Ooh, sounds like spooky, but that is how tilted Uranus is. So just to make the summary of that question, no, the North Star probably won't be the North Star for any other planet in the solar system, unless it was a great cosmic coincidence. But I don't think that that is possible, unless it was a lucky chance on some asteroid that might be rotating in exactly the same alignment as the Earth. I don't know, but that's not the case. But the constellation shapes will be roughly exactly the same from planet to planet, because within the solar system, you're not moving that far relative to the distance to the other stars that make the constellations. So they are so far away that the perspective from Saturn to the Earth is not going to change that. But each planet has its own axis of rotation. They all have their own prerogative. And so that's where you won't get to see the North Star as the North Star anywhere else but here on Earth. And only for now. And I'll probably wrap this up with just saying, I didn't get to explain how this affects the zodiac constellations, but this precession of the equinoxes is a result of that wobbling of the Earth. And if you've heard me talk about this before, the dates that people use in astrology, that's psychic predictions of the future based on the stars. Astrology uses dates that are 2,200 years out of date. Dates that were accurate during the time of the ancient Greeks, but are now inaccurate by about a month because of the precession of the equinoxes, knocking everything out of alignment by about a 12th since the last 2,000 years have passed. So it's a lot of stuff to think about, but we'll talk about that in a future, broadcast of the Planetarium. And just think about this. If you're one of those folks who really is wedded to your zodiac constellation, you're like, oh, I found out that I thought it was a Leo, but actually the sun is going to be, in Virgo on my birthday, or actually it would be in Cancer, but I'd rather be a Leo than a Cancer. I'm sure a lot of people would say, well, don't worry. If you wait, I think something like 22,000 or 21,000 years, those dates will be accurate again. So just hold tight and you get your zodiac sign back again if you can wait 21,000 years for the Earth's wobble to finish that circle that it's been doing for all of human history. So I hope that's enough for you folks today. I hope you can digest all of that. But most importantly, get out there and look for Draco the Dragon. And as some of our guests have told us, go out and look for those Lyrids if you're willing to get up really early before sunrise, like 4:45 or so. That's the best time, perhaps. So otherwise, everyone, thanks for watching. And I hope you keep looking up. And Leela, let me know if there's any last questions from anyone.
No, it looks like you answered all the questions. And they're saying thank you so much. They really, it's great. And again, thank you so much, Bobby, for all of your information. And this same program will be next week on Tuesday, right at 2:30. So we'll get another installment of the night sky. But like Bobby said, please get outside, especially today, because it is finally clear and beautiful. So hopefully you'll see all those things that Bobby just talked about.
And get a spinning top and wobble it around on your tabletop and ponder the Earth as a gyroscope.
That's perfect. Yes, absolutely. All right. Well, thank you so much. We'll sign off, and it was great to see you again.
See you soon. Bye, Leela.
Bye.
Have a good afternoon, everyone.
You too.